All right, everybody. Good morning, or good afternoon, or good noon. We got to get through this. This probably won't take very long for you to actually do, but I'm sure this video is going to take forever. Now, for today, you were supposed to have done number 3 here. The object is standing still. Now, I'm not sure if your particular class, if we had started the motion map and someone had been called or not. So I'm just going to start from scratch on here and hopefully grab the pen, and I guess I'll make it red. So, the object is standing still. There was a lot of debate over how do you show an object on a motion map that doesn't have velocity. Hopefully, you were thinking about it, and you thought, well, arrows are how we show something's moving, so I suppose if it's not moving, we don't have arrows. So, maybe if I just put, oh gosh, this thing is going to be trouble for me, I can tell already. That's, yeah, wow. So that's a big old dot. Maybe I should, Let's try that again. How about, that's a little better, I guess. So there's a dot. The object is standing still. There's a dot and there's no movement. No arrow. Now the next question is, was this happening for just one moment, or did this happen over multiple moments in time? It doesn't really say, and so I'm just going to assume that this didn't just happen for a moment, that this was a repeated thing. It happened over and over. Now what some folks might do is put a dot here, and then maybe another one here. But I don't like that, because what that's doing is it is showing that the object was here, it had no motion, and yet ended up here, further away from the 0 position. And then, sometime later, it ended up out here, even further away from the 0 position, but still no arrows on any of these dots, telling us that there was no velocity, but somehow it was able to change positions. So instead of that, let's see if I can erase these now. Oh, please tell me. Oh, they're not going to erase? Are you kidding me? Oh my gosh. It's not going to... it's not going to erase. That's disappointing. I'll tell you what I can do. No, I can't. Oh, I tell you. That's not even funny. I cannot believe they are not letting me erase. I can't erase. I'm trying to erase right now. I'm rubbing the stylus all over the dang screen, and it is not erasing the pen marks. Well, I'll tell you what I'm going to do. Oh my gosh, I can't even select it. Oh, look at that. I wonder if I can delete it. Can I just delete it? All right, I'm gonna drag these aside. I don't like that. I'm just gonna put those aside. Whew, what a bad situation here. All right, so starting like I did earlier, I would say, all right, there's my object. Now, where can I put the object so that it is the same distance away from the 0 position? So it's not going to go anywhere. It's not going to get further away from the 0. It's not going to get closer to the 0. It has to stay at the same place with respect to the 0. The only place that can happen is directly below the first dot. And then maybe a moment later it was, oh boy, let me see if I can, there we go. And then a moment later maybe it was here. So now what this is showing is this. So I hope you're getting this. If you want to show that an object is staying at the same place but not going anywhere, staying at the same place and not moving, But it's doing that over multiple moments, then you would have a dot and then another dot and another dot. Because we can't stack them up on top of each other or you can't actually see them. If I just keep drawing the same dot over top of the same dot, you don't know there's multiple dots there. Now, I don't know how many of you put the object in a positive position for this. Does it say where the object is standing still? No. So, if you said it was in a positive position, then that's fine. Could you say that it was in a negative, in a zero position? Could the object be in position 0? Yeah, that works. Could we say that the object was, I can move this around, in a negative position? Is it? Oh my gosh. Whoa. Are you kidding me right now? So, we could say that the object's in a negative position. We could say the object is in a positive position. We could say the object is at the 0 position. Any of those things are fine because it doesn't actually, it doesn't actually tell us in the statement. So, I must drag those aside as well. I must stick with what I said first. Now, to determine what the position time graph is, how do I show that the object was at a positive position and did not move from that positive position? Well, where are positive positions? Up here. How can I show that it stayed at the same positive position, didn't get further away from 0, didn't get closer to 0? Well, the only way I can do that is by making a line that's horizontal. That line now is telling me that this object is at a positive position, not going anywhere, not changing direction, not changing position. It's just there. Now, I want you to think about something here. The slope, hold on, before I even do that. The slope of this line, no. What is happening here? So, the slope of this line is 0. And what does the slope of the position time graph tell us? Velocity. The slope of the position time graph is velocity. So the way we describe the slope here of the position time graph is how we describe velocity. And that line I just drew on there has 0 slope. So that means we have 0 velocity. Now, when I was dragging this thing around, oh my gosh, stop it. When I was dragging this thing around, what is happening right now? There. So when I was dragging, this thing is terrible. Oh my gosh. All right, now, it's at the 0. That would be true if, now I can't even move them together. So now they match. 0 position on the motion map, 0 position on the XT graph. Oh my gosh. Now, oh my gosh. Now they match. So they match now, they matched a second ago. I hope all this stuff is coming through in the video because all this movement, oh my gosh, this thing is so messed up. So anyway, that's how that's supposed to look. Now, finally, Lord have mercy, we're getting to the VT graph. So if I want to draw the VT graph based on what we're saying here, what do we have here for velocity? We have none. Standing still, no arrows, no slope. That means I have to be at 0 velocity here. And where's the velocity 0 on the VT graph? Right here on the t-axis. So my line here has to be right there. That tells people, hey, the velocity is 0 and it stays 0 the whole time. Got that? I hope you got that. Let's see what else. Ooh, another question that I asked everybody yesterday or today. Well, it's today, but for you it was yesterday. What if, and it's probably not going to work anymore. I probably can't move. Oh, I can. What if I pull that down to here and I move these back over where they were a second ago? Oh, no, 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 no. All right, move those over. So now, oh no. What is happening? Oh no. Oh my, this thing is so jacked up. I don't even know what's happening. All right, now I have to move that again. Okay, so now we have, again, what? Oh my gosh. I got to undo something here. I don't even know what that was. Okay. This thing is about to kill me. Okay, anyway, the point is this. Now this is at the zero position. This is at the zero position, and the question is, does making those changes, does that affect what this graph looks like? So does the fact that this object is now motionless at position 0, and this one's now motionless at position 0, does that change the fact that this graph says that the object has no velocity? I hope you're thinking no. I hope you're thinking the answer to that question is no. Because the fact that this object is at zero position and that this object is at zero position, standing still, that does not change the fact that this graph shows zero velocity the whole time. So the implications are that this graph here can't show us something. There's something about this, the motion map, and our position time graph that we can't see on the velocity time graph. I hope that you get that. What can't you see? Position. You should put this in your notes. Oh no, this thing isn't. There we go. Position. Cannot be seen. Oh boy. On a V versus T graph. There we go. Put that in your comp book. Position cannot be seen on a V versus T graph. It is unaffected. The VT graph is unaffected by where the object is. It can only tell us the how fast part and the what direction. Now, also, something else you should probably add in your comp book. The slope here, the slope of this graph, the xt, that tells us what? I hope you're thinking the word velocity. So that's what that tells us. The velocity is the slope of that graph. So whatever words you use to describe the velocity, those are the words we're using to describe oh my gosh, I can't even think right now. It's been a long day. Whatever words you use to describe the slope right here, the same words describe the velocity, because that's what it means. This slope is the velocity. And if you say that has zero slope, we're saying it has zero velocity. That's what we're saying. Slope of the xt graph is velocity. And position can't be found here. You do not see any position on this graph. This only tells you velocity. This one tells you position. This one tells you velocity. Okay, my gosh, 15 minutes. I didn't think that was ever going to end. Okay, they won't all be this long. I don't know. They might. I don't even know. I think I'm going to have to send this out as its own separate video. 15 minutes. Okay.